Number 4 has 1, 2, 3 terms. I notice that there isn't a GCF because I don't have a y here, and I only have a 1 as a coefficient here, so we're not going to have a GCF. This has 3 terms, so looking at the flow chart, 3 terms means to use quadratic form. Now this is not a quadratic, it's a quartic. However, we can still take the square root of y to the 4th, just like we take the square root of a y squared up here. We had a y squared and we put a y in both places. So think about that. If instead we have a y to the 4th, then instead of putting a y in both places, I need to put a y squared in both places. After that, I can just use my quadratic form and factor like I would if it was a quadratic. So it's taking the form of a quadratic even though it's not one. All right, so let's take a look. I want factors that multiply to be negative 48 and add to be negative 13. 48 has a lot of factors, so I'm going to go ahead and go over here to the side and do a T-chart like we used to do whenever we weren't sure by just thinking with our brain real quick what the factors might be. I also noticed that the middle term is negative. That means that the negative sign needs to go in the bigger factor. So I'm going to factor 1 and negative 48, 2 and negative 24. 3, negative 16, 4, negative 12, 6, negative 8. And the two factors, the line that works to add to negative 13 would be this 3 and negative 16. So those are my factors that I'm going to write. So plus 3 and minus 16. Now, I can't say that I'm done because I don't have a monomial or a linear factor. I have a quadratic and a quadratic because I have a squared here. So I need to look at each of these individually. I'm going to focus first on y squared plus 3. Go up to my chart knowing that I have positive. This is a perfect square, but 3 is not. 3 is prime, so it's not a perfect square. Let's see what that tells us. I have 2 terms and the operation is addition. I had a plus sign there. I need to either have perfect cubes or not. I do not have perfect cubes. In fact, they aren't even perfect squares, not both of them, that 3 isn't. So either way, that means it is not factorable. So let's make ourselves a note so we won't wonder why we didn't do anything with that y squared plus 3 since it has a squared on it. Just come out to the side and say, can't factor. You can't factor this any further. Now let's take a look at y squared minus 16. You might recognize that that's the same thing that we just did up here, y squared minus 16, and we saw that it was difference of 2 squares. So we can just go ahead and kind of cheat a little bit and just write this without looking at our flow chart again. So we are going to use difference of 2 squares. The unfactorable part, the y squared plus 3, is just going to kind of come along for the ride at this point. We can't do anything else with it except leave it. But the y squared minus 16 will break into y plus 4 and y minus 4. Now, I have a quadratic here. I've got a squared, but I already decided in the last step that I can't factor it, so I'm done with that one. This one has linear now. So am I done? Yes. Yes, I am. All I need to do is box this as a final answer. All right, problem number 5. We have 16x to the 4th minus 81. So let's go ahead. We've got 2 terms. Neither of these is going to give me a greatest common factor. So I just need to deal with what I have. I don't have anything else that I can do with it until I just start factoring. I am going to notice that 16 is a perfect square, so is 81. X to the 4th is also a perfect square. It's not the perfect square of x, it's the perfect square of x squared. Because if you take x squared and multiply it by x squared, you get x to the 4th power. Remember, when you multiply, you add exponents. All right, so I do have 2 perfect squares and a negative sign between them. I'm going to use that information up here in my flowchart if you need to look at it. Remember, eventually you want to get to where you don't rely on the flowchart. I have 2 terms, subtraction, both terms are perfect squares. I will use difference of 2 squares to factor. So let's do that. Remember that the format is to put the square root of the first term in the front and the square root of the last term in the back. Square root of 16 is 4. Square root of x to the 4th is x squared. Another 4x squared. The square root of 81 is 9. And I need one with a positive sign and one with a negative. So this is difference of 2 squares. And now I need to look at each term individually, or each parentheses, each binomial, and see if I can do anything else with them. All right, so notice that 4x squared is a perfect square, and so is 9. I have a plus sign here, so let's see what that tells us. The operation is addition with 2 terms. Both terms are not perfect cubes, they were perfect squares. So if they're not perfect cubes, we can't factor. Remember, we said at the very beginning that there's no such thing as factoring a sum of 2 squares, which is what we have, something in the format of a squared plus b squared. Let's go ahead and say for this one that we can't factor anymore. But this other one has a minus sign. Hopefully you've gotten used to by now, if we have perfect squares and a negative between them, we are going to use the difference of 2 squares. If not, use your flowchart until you don't need to use it anymore. Next line will be 4x squared plus 9, the thing we couldn't do anything with, but we can break this up into 2x in the front when I take the square root of 4x squared, and then a plus and a minus 3. I now have an unfactorable piece here. I already determined that. Both of these are linear, so when I ask myself, am I done? The answer is yes.